In this video, I will discuss the calculation of number of particles in unit cell. In a unit cell, there are lattice points where particles are present, but we have to understand that the particle which is present does not exist completely inside that unit cell. It might be shared by 2, 4 or 8 other unit cells. So in a unit cell, completely whole particle or whole sphere is not present. Due to this, the number of particles present in a unit cell has different value as there are the number of lattice sites in the unit cells. Now, so the first unit cell is simple or primitive unit cell. I have discussed that in simple or primitive unit cell, the particle is present at the corner. So the center of the sphere or particle coincides with the corner of the unit cell. So here you can see that only this much portion exists inside this unit cell and remaining this whole area is outside the unit cell. So we can't say that this whole whole sphere or particle has been is present inside this unit cell. Okay, so to find out that how much portion of this sphere is present inside this unit cell, we have to see that how many unit cells can be made by using this corner as one of the lattice point. So 2, one back side, one this side, so 4. These 4 are present at ground level, means you can say that ground floor, and it covers nearly 50% of the sphere, but still the 50% of sphere lies upward. So here also on the top side also we will have 4. So total 8 unit cells can be made from the single corner. It means that the sphere or particle present at this corner will be shared equally among 8 unit cell. So the contribution inside the one of the unit cell is only 1/8. Contribution. So from corners 1/8. Now see here. Now this is clear that contribution from corner is 1/8. Okay, then how many corners are present in a unit cell? There are 8 corners and all those corners are occupied by one sphere or particle. So total number of particles equal to 1/8 into 8, and it comes around 1. Okay, so in a simple or primitive unit cell, total number of particle is 1, but lattice points are 8. Okay, so this you have to remember that what is the contribution from the particle which are present at corners of the unit cell. Okay, now second type of unit cell is body centered unit cell, or we call it BCC in short form. In body centered unit cell, eight are present at the corners and 1 is present inside the unit cell at the center of the unit cell. So how we can find out the center of the unit cell? We have to draw 2 diagonals, body diagonals, and the point where the body diagonals intersect each other act as the center of the unit cell. If the particle is present at the center of the unit cell, then definitely it has not been shared by any other unit cell and it completely lies inside the unit cell. So contribution from body center is 1, means complete. So here, in case of BCC, contribution from corners equal to 1 by 8 into 8, that is equal to 1, and contribution from body center equal to 1. So total number of particles equal to 1 plus 1, that is equal to 2. Okay, so now, so in body centered unit cell we can say that total number of particles are 2, but the total number of lattice points are 8 plus 1, 9 lattice points. Okay, now third is face centered unit cell. In case of face centered unit cell, particles are present at the 8 corners. Okay, particles are present at the 8 corners, and each and every face center. So there are 6 face centers, 6 faces in a unit cell, means top, bottom, front, back, and right, left. If I am standing inside the unit cell, then there are 6 faces, and each face will have its own center, and one particle has been placed at the center. So if we see a face of the unit cell can be shared by 2 unit cells. Okay, so contribution within one unit cell is half only, because half will remain in other unit cell. So contribution from face center is 1 by 2. So here contribution from corners equal to 1 by 8 into 8, that is equal to 1. Contribution from face centers equal to 1 by 2 into 6, that is equal to 3. So total number of particles in FCC equals to 1 plus 3, that is equal to 4. Clear? So this is the number of particles present in face centered unit cell or FCC. But if we look at the total number of lattice points, then 8 from corners and 6 from face center. So there are 8 plus 6, 14 lattice points in a face centered unit cell, but total number of particles which are present is only 4. Okay, now sometimes particles are also present at the edge center. If a particle occupies edge center, then contribution in one unit cell will be only 4, 1 by 4th, because one edge can be shared by 4 unit cells. Okay, so the contribution from edge center is 1 by 4. Okay, now we will see some of the numerical problems which comes in examination regarding the calculation of number of particles in unit cell. Okay, note it down fast. Now let us deal with some of the problems which comes in examination with calculation of number of particles in unit cell. So the first question is, in a unit cell, A is present at all the corners and B occupies all face centers. What will be the formula of compound? So here A, how many number of A are there in the whole unit cell? So we have to see that A is present at all the corners. So contribution from corner is 1 by 8 and there are 8 corners. So total number of A present is 1. Okay. Similarly B occupies all face centers. So contribution from face center is 1 by 2 and there are 3 6 face centers, so multiply by 6 and the answer becomes 3. So the formula of the compound is A1B3. Okay, now let us deal with second problem which you may face in your examination. The second problem is A, B and C occupies all corners, face centers and body center. What will be the formula of compound? So it is also very easy. A occupies all corners, so 1 by 8 into 8, that is equal to 1. Similarly, B occupies all the face centers, 1 by 2 into 6, that is equal to 3. Similarly, C is present at face body center, so in body center contribution is 1, so C is 1. So formula becomes A1, B3, C1. So this is the formula of compound and this is the answer of the given problem. Okay, so this is the way how we deal with the problems related to contribution of particles. Note it down.